DevOps is an operational process that integrates software and operations teams to enable faster development and deployment of applications. It is an agile methodology that focuses on collaboration and automation, which helps to bring products to market faster while also improving their reliability and quality. The primary goal of DevOps is to improve the speed, quality, and efficiency of software development by using automation tools, collaboration, and continuous feedback loops. DevOps focuses on eliminating manual processes and automating tasks that have traditionally been done manually. This helps to reduce time spent on mundane tasks such as configuration management, testing, deployment, maintenance, and monitoring. As a result, organizations can focus more on innovation rather than maintenance of existing systems. The most essential components of DevOps are continuous integration, CI, and continuous delivery/deployment, CD/CD. CI is a process in which developers continually integrate their changes into a shared repository like GitHub or Bitbucket. This allows them to collaborate better as well as identify issues early in the development cycle before it's too late for corrections. CD/CD is the process of automating deployments so that any code changes made by developers can be quickly pushed out into production environments with minimal effort from operations teams. In order to successfully implement DevOps, organizations need to build reliable infrastructure that can support automated test runs, deployment pipelines, release management processes, and continuous feedback loops with customers. This requires setting up CI/CD pipelines on cloud platforms such as AWS or Azure, or using open source tools such as Jenkins or Travis CI that are designed for this purpose. These pipelines should be integrated with the source code repository so that new code can be automatically tested before being deployed into production environments. Additionally, the organization needs to have well-defined governance policies in place so that only approved changes are released into production environments. This ensures stability and consistency across all environments where applications are hosted. Once the infrastructure has been set up properly, then the organization needs to define effective procedures for deploying applications. This includes setting up deployment strategies such as blue-green deployments or rolling deployments, which enable zero downtime when releasing new features or bug fixes into production environments. Additionally, organizations should set up alerting systems so they can be notified if something goes wrong during an automated deployment process or if there's an issue with one of their applications running in production environments. Finally, organizations need to ensure they are collecting feedback from customers about their applications running in production environments so they can take corrective measures quickly if necessary. They should also use analytics tools such as Splunk or ELK Stack for monitoring application performance in real time so they can detect potential issues before they become problems for users who are interacting with their applications in production environments. In summary, DevOps provides organizations with a way of implementing reliable processes for rapid software development while also maintaining high levels of quality assurance across all stages of application lifecycles from development through releases into production environments. To successfully implement DevOps, it requires organizations setting up proper infrastructure solutions combined with effective procedures for deploying applications while also incorporating continuous feedback loops with customers into their processes. DevOps is a set of practices that combines software development and information technology operations. It is intended to shorten the system's development life cycle while also delivering features, fixes, and updates frequently in close alignment with business objectives. DevOps fosters collaboration, communication, and integration between software developers and IT operations professionals. To help guide individuals who are interested in embarking on a DevOps journey, this roadmap provides a framework to get started. The first step is understanding the basics of DevOps. This includes gaining an understanding of what it is and how it works. Additionally, learning about key concepts such as version control, continuous integration/delivery/deployment, automation, orchestration, monitoring and logging, and infrastructure as code will provide an essential foundation for further exploration. This step also includes familiarizing oneself with the various DevOps tools available, example Jenkins, Chef/Puppet, Ansible. Once comfortable with the basics of DevOps, it's important to create a plan for adoption within one's organization. This should include mapping out the various stages of adoption, example, discovery/assessment, planning and design, and identifying which parts of the organization will be impacted by DevOps, example, engineering teams. Additionally, strategies for change management need to be developed as well as ways to measure success, example, cost savings from automation. The third step is implementing the plan outlined in step 2. This includes designing a solution architecture based on requirements gathered from stakeholders as well as selecting appropriate tools for automation and orchestration purposes, example, Jenkins for CI/CD pipelines. Additionally, implementing processes such as version control management using Git or other similar tools will allow teams to collaborate more effectively on code changes while also tracking their progress over time. Additionally, operational processes should be automated wherever possible, example, server provisioning, to increase efficiency and reduce errors that can occur during manual processes. Once all the pieces are in place, then it's time to test and validate the implementation against goals and objectives set out in step 2, while also gathering feedback from stakeholders throughout the process so any necessary changes can be made quickly before full deployment into production environments takes place. Lastly, once everything has been validated, then it's time to deploy into production environment where ongoing maintenance and monitoring can take place using existing tools such as Nagios or Splunk, etc. Additionally, this is where additional testing such as performance tuning and security testing can take place before new features are released into production environments, ensuring only high-quality applications make it through this final stage of deployment into customer-facing environments where potential impacts on user experience can be minimized significantly due to proper testing taking place prior to release cycles taking off into production environments, where end users actually receive these new features/fixes, etc. In conclusion, adopting a DevOps approach offers many advantages over traditional methods when it comes to software development lifecycles, but there are many challenges along the way which require careful planning and implementation in order for organizations to reap maximum benefit from their investment and time spent on adoption journeys towards achieving enterprise-wide DevOps success stories. DevOps is a highly sought-after job in the IT industry today, and can provide a lucrative salary both in India and abroad. This article will provide an overview of the salaries that DevOps engineers can expect to earn in India and abroad. In India, DevOps engineers usually draw an average salary of 7 to 13 Indian rupees lakh per annum, depending on their experience level. Junior DevOps engineers may earn something close to 4 to 7 Indian rupees lakh per annum, while senior DevOps engineers may draw salaries around 9 to 13 Indian rupees lakh per annum. The salaries also vary depending on the company they work for and the location they are based out of. Companies based out of Bangalore, Mumbai, Pune and Hyderabad tend to pay higher salaries compared to those in other smaller cities. As such, it is important for an engineer looking for a job in DevOps to understand their local market better before applying for a job. The salaries also vary according to the skill set that the engineer possesses. Automation skills are particularly valuable as they allow an engineer to perform tasks faster and with greater accuracy than manual approaches. Additionally, knowledge of scripting languages such as Python, Ruby, or Golang is highly sought after by employers as well, since these allow for faster development times and easier maintenance of existing codebases. Consequently, having knowledge about these languages can help an engineer fetch higher salaries than their counterparts who do not possess them. For DevOps engineers looking for higher pay packages abroad, there are plenty of opportunities available across countries such as the United States, Canada, Australia, etc. With experience levels ranging from junior to senior roles, these countries pay anywhere between $80,000 to $150,000 per annum depending on the company and level of experience possessed by the engineer. Moreover, software product companies tend to pay slightly higher than internet service companies when it comes to DevOps engineers, which must be taken into consideration as well before applying for jobs abroad. Fixed-term contracts also exist which typically offer high pay packages but require long working hours too. Hence, before taking up such contracts, it is important for an engineer to understand their own boundaries with respect to how much time they can dedicate towards work on a daily basis before making any decisions about accepting one or not. Overall, working as a DevOps engineer can be quite rewarding both financially and professionally if one knows where to look and what skills they need in order to succeed in this field effectively. DevOps technology is a term used to describe the collaboration between software developers and IT operations teams. It is a set of practices that enable organizations to improve the speed, stability, and security of their software applications. DevOps technologies enable teams to quickly identify, troubleshoot, and correct issues as they arise, ensuring that applications remain secure and reliable. In this video we'll discuss some of the most popular DevOps technologies available today. First, let's take a look at source control management, SCM, systems. These systems are used to manage the source code for an application or other software project. They provide version control so that developers can easily keep track of different versions of their code, as well as allow for collaborative development and easy distribution of new features or bug fixes. Popular SCM systems include Git and Subversion. Next up is continuous integration, CI. This practice enables teams to quickly check in their code changes into the shared repository and then automatically trigger builds and tests on each commit. This helps ensure that any new code introduced into a project does not cause any issues with existing components. Popular CI tools include Jenkins and TeamCity. Continuous delivery, CD, is another important practice in DevOps technologies. CD pipelines help automate the process of building, testing, and deploying applications so that projects can move quickly from development through production without manual intervention or delays caused by broken builds or failed tests. Popular CD tools include Spinnaker and GoCD. In order to maintain high levels of service quality in production environments, it's important to use monitoring tools to monitor application performance. These tools provide real-time visibility into system health metrics such as CPU utilization or memory usage, which can help teams quickly identify potential problems before they become serious issues for users or customers. Popular monitoring tools include Prometheus and Datadog. Finally, configuration management tools are used to ensure consistent configurations across all servers in a production environment by automating the configuration process from dev/test through staging/production environment, so teams don't have to manually configure servers every time they need to deploy an application update. Popular configuration management tools include Ansible and Chef. As you can see, there are many different DevOps technologies available today that can help your organization increase speed, stability, and security when building software applications. By adopting modern DevOps practices such as source control management systems, continuous integration pipelines, continuous delivery pipelines, monitoring tools, and configuration management systems, you will be well on your way towards creating reliable software solutions that meet customer needs faster than ever before.